We use many substances in our everyday life. Lemon, tamarind, salt, sugar, baking soda are part of our food. Tamarind is sour. You may remember how teeth go on edge if you have eaten a lot of tamarind. Lemon juice, buttermilk, yogurt are sour to taste. The food tastes sour because they contain acids. These acids are natural and mild. What is the taste of baking soda, lime, soap, ash? They have a sharp, astringent taste. If mixed in water, their solutions are soapy to touch. You may have at some time slipped on soap water spilt on the floor. These substances are called bases. Acids and bases have mutually opposite properties. Children, always remember that it is wrong to touch or taste a substance to find out what it is. It can be dangerous to do so. How can you recognize whether a given substance is an acid or base? Certain substances are used to find out if a given substance is an acid or a base. These substances are called indicators. When an indicator is added to an acidic or basic solution, it changes color. Litmus, turmeric are some examples of indicators found in nature. Phenolphthalein, methyl orange are some other indicators. Let us learn about litmus, a natural indicator. Generally, litmus is used to identify acids and bases. It is obtained from plants called lichens. A solution of litmus in water is purple in color. If it is added to an acid, it turns red, and if added to a base, it turns blue. Litmus is available either as a solution or as strips of paper called litmus paper. You get both red and blue litmus papers in the market. Let us use the litmus to identify whether the given substances are acid or bases. Take two test tubes. In one test tube, take a solution of lemon juice and in the other a solution of quicklime. Dip one red litmus and one blue litmus paper in each of the test tubes. Observe both litmus papers carefully. What do you see? In the lemon juice solution, the red litmus paper remains red and the blue litmus paper turns red too. On the other hand, in the quicklime solution, blue litmus remains blue and the red litmus also becomes blue. Now, prepare solutions of a detergent, soap, shampoo, salt, sugar, washing soda, vinegar, tamarind, etc. Take some samples of tea, milk, yogurt too. Test all these substances with both red and blue litmus paper and record your observations in this table. Let us make a list of the substances which do not have any effect on the color of the litmus paper. In detergent, red litmus turns blue and blue litmus remained blue, so it is a base. In soap solution, also, red litmus turned blue and blue litmus remained blue, so it is also a base. In shampoo too, red litmus turned blue and blue litmus remained blue, so it is also basic in nature. In salt solution, red litmus remained red and blue litmus remained blue, means it is neutral. In sugar solution also, red litmus remained red and blue litmus remained blue, means it is also neutral. In washing soda, red litmus turned blue and blue litmus remained blue, so it is basic in nature. In vinegar, red litmus remained red and blue litmus turned red, so it is acidic. In tamarind juice also, red litmus remained red and blue litmus turned red, so it is also acidic in nature. In tea, red litmus remained red and blue litmus remained blue, means it is neutral. In milk too, red litmus remained red and blue litmus remained blue, means it is neutral. In yogurt, red litmus remained red and blue litmus turned red, so it is also acidic in nature. From the list of the substances, solutions of salt and sugar, tea and milk did not show any effect on the color of the litmus paper. Those substances which do not affect either red or blue litmus paper are said to be neutral substances. Neutral substances do not show the properties of either acids or bases. Remember, there are chemicals like acids and bases in the laboratory. These chemicals are corrosive and should be handled with great care. Hence, experiments involving such chemicals should be done only under the supervision of a teacher. Let us try this. Obtain dilute solutions of hydrochloric acid, that is HCl, sulfuric acid, that is H2SO4, acetic acid, that is CH3COOH, sodium hydroxide, that is NaOH, calcium hydroxide means slaked lime, that is CaOH twice. You can make the dilute solution by adding water. Add litmus paper and phenolphthalein to each of these solutions and write your observations in the following table. Solutions. In hydrochloric acid, red litmus remains red and blue litmus paper turns red. In sulfuric acid also, red litmus remains red and blue litmus paper turns red. In acetic acid too, red litmus remains red and blue litmus paper turns red. In calcium hydroxide, red litmus turns blue and blue litmus paper remains blue. In sodium hydroxide too, red litmus turns blue and blue litmus paper remains blue. When phenolphthalein is added in hydrochloric acid, sulfuric acid, acetic acid, we cannot see any change. But when phenolphthalein is added in calcium hydroxide and sodium hydroxide, it turns pink. Elements fall into two groups, metals and non-metals. Some elements, when burnt in air, combine with the oxygen in air and form oxides. When metals are heated, oxides are formed. When a magnesium ribbon is burnt, magnesium oxide is formed. Like magnesium, sodium is also a metal. When sodium is heated, it combines with oxygen in air and forms sodium oxide. Non-metals too form oxides when heated. When sulfur is heated, it combines with oxygen in air and forms sulfur dioxide. Let us try this experiment. Take some powdered sulfur in a deflagrating spoon. Heat it over a burner or a spirit lamp. Soon, the sulfur begins to burn. Now, quickly put the spoon in a gas jar and close the jar with a lid. The yellowish sulfur dioxide gas gets collected in the gas jar. Move the lid aside a little and remove the spoon. Add 20 to 25 milliliters of water to the jar. The gas in the jar dissolves in the water and we get a solution. Put red and blue litmus papers in the gas jar. The blue litmus turns red and the red litmus remains red. What do you infer from this? Generally, oxides of nonmetals are acidic. When they dissolve in water, they form acids. Hydrochloric acid, sulfuric acid, and nitric acid are strong acids. In an acid, the main constituent is H. It is H that makes it acidic. Let us try another experiment. We saw that when magnesium burns in air, we get a powder of magnesium oxide. Take this powder in a test tube and add water to it. We get magnesium hydroxide. Take a little of this solution in 2 test tubes and place blue litmus paper in one and red in the other. You will see that the red litmus paper becomes blue while the blue one remains blue. Generally, oxides of metals are basic. Sodium oxide, magnesium oxide, calcium oxide are some examples of oxides of metals. When these oxides dissolve in water, they give respectively the bases called sodium hydroxide, magnesium hydroxide, and calcium hydroxide. Oxides of some metals, like copper, do not dissolve in water. Their hydroxides are prepared using some other chemical reaction. Hydroxides of metals are basic. The main constituent of bases is OH. It gives them their basic properties. Bases that dissolve in water are called alkalis. Thus, all alkalis are bases, though all bases may not be alkalis. We saw that acids turn blue litmus red, while bases turn red litmus blue. What happens when a base is added to an acid? To answer this question, let us first study neutralization. Neutralization. First, prepare dilute solutions of hydrochloric acid and sodium hydroxide. In a test tube, take 5 milliliters of dilute hydrochloric acid. Note the color of the solution. Note the color of the indicator phenolphthalein. Add 2 or 3 drops of this indicator to the acid. Did the acid change color? No. Now, using an ink dropper, add the dilute solution of sodium hydroxide to the hydrochloric acid solution drop by drop. Keep shaking the test tube gently and watch to see what happens. Keep adding the sodium hydroxide solution drop by drop to the hydrochloric acid till it becomes faintly pink. Keep shaking the test tube occasionally as you do this. Now, add hydrochloric acid drop by drop to this pink solution in the test tube. What do you see? The solution becomes colorless. Now add sodium hydroxide again drop by drop to the colorless solution. What change do you see in the color of the solution? It turns pink again. When the solution is alkaline, the phenolphthalein gets a pink color, and when it is acidic, the indicator is colorless. When an acidic solution mixes in a basic solution, the reaction between them results in the formation of a new substance called a salt and water. The chemical reaction that takes place is shown below. Sodium hydroxide plus hydrochloric acid gives NaCl, that is, common salt and water. The chemical reaction that takes place between acids and bases is called neutralization. It results in the formation of salt and water. Now let us come to the classification of salts. When salts dissolve in water, they form a solution. These solutions are acidic, basic, or neutral. Let us learn about them. Neutral salts. Salts formed as a result of chemical reactions between a strong acid and a strong base is neutral. Common salt, sodium nitrate, and sodium sulfate are examples of neutral salts. Acidic salts. Salts formed as a result of chemical reactions between a strong acid and weak base are acidic. When hydrochloric acid, which is a strong acid, reacts with ammonium hydroxide, which is a weak base, it gives ammonium chloride, which is an acidic salt, and water. Aluminium chloride, ammonium sulfate are also acidic salts. Basic salts. Salts formed as a result of a reaction between a strong base and weak acid are basic salts. Washing soda, that is sodium carbonate, baking soda, that is sodium bicarbonate, are basic salts. Everyday use of acids and bases. Lemons, oranges, sweet limes contain citric acid. We get vitamin C from these fruits. The tartaric acid in tamarind and lactic acid in yogurt makes our food tastier. Hydrochloric acid is used for cleaning toilets. Acetic acid and benzoic acid are used for preserving jams and pickles. There is hydrochloric acid in our stomach. It helps to digest our food easily. However, if there is more hydrochloric acid than we need in our stomach, it causes indigestion. Sometimes we get a stomachache. As a remedy for this, doctors prescribe medicines that are basic in nature. Generally, they contain magnesium hydroxide. This neutralizes the extra acid in the stomach. Overuse of chemical fertilizers makes the soil acidic. At such times, quicklime or slaked lime is added to the soil. If, however, the soil has become alkaline, organic substances are added to the soil. Some acids are formed due to these organic substances and they neutralize the alkalis in the soil.